Hello everyone, my name is Nazym and today we're going to solve problem number 38 from the Randall book. Okay, let's get started. A minus 10 nanocoulomb point charge and a plus 20 nanocoulomb point charge are 15 centimeters apart on the x-axis. And in scenario A, we have to find what is the electric potential at the point on the x-axis where the electric field is 0, and B, we have to find what is the magnitude of the electric field at the point on the x-axis between the charges where the electric potential is 0. Okay, let's get started. First, let's write what is given so it would be more clear. Okay, so let's start. We have point charge number 1, which is equal to minus 10 nanocoulomb. Let's put the right units. So it's going to be minus 10 nanocoulomb multiplied by 10 to the power of 9 coulomb. Next, we have point charge number 2. It is equal to 20 nanocoulomb. So in the right units, it's going to be 20 multiplied by 10 to the power of minus 9 coulomb. Okay, now the distance between them is 15 centimeters. And in meters, that's going to be 0.15 meters. Okay, so in scenario A, we have to find the electric potential where the electric field is 0. And in B, we have to find what is the electric field where the electric potential is equal to 0. Okay, let's start solving. So first, in order to find the electric potential, let's first draw the figure. So we have the x-axis. We have 2 point charges. And we know that they're 15 centimeters apart. Okay, so first, in order to solve this, so we know that the electric field is 0. So let's use each point's electric charge. Because they have this opposite directions and the same magnitude, we can equalize them because we know that their addition is equal to 0. Okay, so let's write the formula for each one. So electric field, the formula of electric field for point charge is equal to Coulomb's constant multiplied by Q and divided by R squared. Okay, so for the first point charge, this is the formula, and for the second point charge, the formula is the same, but we're gonna use the second point charge. Okay, so we know that they're 15 centimeters apart, so let's write the second distance. Let's write the first distance as just x squared, and the second distance, let's write it like x plus 0.15 in square. Here we have to find x. X is the distance to the left of Q1. Okay? We know that, as I said earlier, their addition is equal to 0. So it means that they are the same because their magnitudes the same and their opposite direction. So now let's write each formula. electric field 1 is equal to electric field 2, which is equal to Coulomb's constant multiplied by minus 10 divided into x squared equal to k multiplied by 20 and x plus 0.15 in square brackets. Okay, now let's cross out the Coulomb's constant because it's the same value. So now let's use the cross multiplying method to calculate our x. Okay, so here we're going to multiply 10 and 20 as x squared, or as x. Let's write it here. 10 multiplied by x squared plus 0.15 into square equal to 20 multiplied by x squared. Okay, now let's find the x. Here I will use an app to generate it. First value of x is equal to minus 0.0621. The second value of x is equal to 0.362. Okay, so we're not going to use the first value because it is minus. For the distance, we only use the plus value. Okay, now we found the distance. It is in meters. Let's now find our electric potential. So as I said earlier, the distance will be left to Q1, and it is equal to 0.362 meters. Okay. Now we have the distance. Now we can calculate our electric potential. So let's use the same formula and the same logic. Now we have all the numbers and the same formula. Okay, let's put the Coulomb's constant before the brackets because, okay, we have the first point charge, our distance, plus the second point charge, divided by our second distance, okay, let's erase this, and it is equal to 0.3 volts. So here we have the first answer. Let's write it down. Okay, so we have the answer values. Okay, the A, we already found it. As we said, it's gonna be 103 volts. This is the electric potential where the electric field is equal to 0. Okay, now we have to find the B part. Let's erase the previous writings. let's erase the previous parts because we won't use them. Now for part B, we have to find the electric field where the electric potential is equal to 0. Okay, now let's write those. B part is equal to electric. Here we know it from the text that our x is located between 0 and 0.15. Now let's calculate them. We're going to use the formula k multiplied by q1 divided by x plus k, our Coulomb's constant, charge 2 divided by 0.15. Now we're gonna subtract the x from our 15 centimeters. Okay, so we know that this is equal to 0, so we can equalize the two. We can cross out the the Coulomb's constants because they're the same value. Now we're going to use the cross multiplying method again. Okay, let's write all the values in. And here also, now we have to find x. So our x, let's write it 10 multiplied by 0.15 minus x is equal to 20x. Okay, so here our x is equal to 0.05 meters. Okay, now let's put in the values. So our electric potential or electric field is equal to electric field for point 1 plus electric field for point 2. Okay, let's write in. As we said previously, we're gonna open those two values like this and just add them. We can get the Coulomb's constant out of the brackets because they're the same value. Okay, let's now put all the numbers and calculate our final value. Okay, we have our first point charge, our distance, which we found out that it is gonna be 0.5 meters, and we have to put it in square. And our second value is 20 nanocoulomb divided by 0.01. Okay, now let's calculate this. It's gonna be 54,000 newtons divided by coulomb, which is equal to 5.4 multiplied by 10 to the power of 4 newtons divided by coulomb. This is our second answer. Now let's write it down. Okay, thank you. I hope everything was very clear, and I hope you understand everything. Thank you for your attention. I hope that I helped you to solve this problem.